Hello, my dear students. This is Dr.M.VIJAYASANKAR, Assistant Professor, Department of Statistics. Our today's topic is Poisson distribution. In this video, we are going to discuss about how to find mean and variance of the Poisson distribution by using moment generating function. Our moment generating function is mx of t equal to expectation of e per tx. This is equal to summation of x equal to 0 to n into e per tx into p of x. The p of x is rewritten as probability of x equal to small x. Here the probability of x equal to small x is nothing but the probability mass functions. Our probability mass function of Poisson distribution is e power minus lambda power x by x factorial. Using these probability mass functions in the above equations, we get summation of x equal to 0 to n into e power tx into e power minus lambda power x by x factorial. Here the e power minus lambda is a constant, so we are taking the e power minus lambda in the outside from the equations. So the above equation is rewritten as e power minus lambda summation of x equal to 0 to n e power tx the lambda power x by x factorial. Now we are going to substitute x equal to 0 to n in this equation. Before substituting the x equal to 0 to n, again we are going to simplify these equations because the e power t is having some power of x and lambda is also some power of x. The taking the power x in the common. So that only the above equation is finally rewritten as e power minus lambda summation of x equal to 0 to n into lambda e power t whole power x divided by x factorial. The same equation is repeated in this slide. Now putting x equal to 0 and x equal to 1 and x equal to 2 and x equal to 3 in the above equations. So putting the x equal to 0, we get lambda e power t whole power divided by 0 factorial, and putting x equal to 1 we get lambda e power t whole power 1 by 1 factorial, and put x equal to 2 we get lambda e power t whole square divided by 2 factorial, plus put x equal to 3 we get lambda e power t whole power 3 divided by 3 factorial. Now going to simplify the first terms because the 0 factorial answer is 1 and lambda e power t whole power anything power 0 values is also 1 and e power 0 values is also 1. So that only we are going to simplify this second term like that in the third equations, that is e power minus lambda e power t whole power 0 is 1. So 1 divided by 0 factorial values is also 1 plus remaining terms are same. Lambda e power t whole power 1 by 1 factorial plus lambda e power t whole square by 2 factorial plus lambda e power t whole cube divided by 3 factorial. Now the same equation is also repeated here. Now applying exponential series because we are going to simplify this above equations. That is why we are using the exponential series here. Our exponential series formula is e power x equal to 1 plus x by x 1 factorial plus x cube by 2 factorial plus x cube by 3 factorial. See the equation in the above, compare this equation in the above equation. Both the equation will be similar. So that only we are going to find the e power x values by using the exponential series. Now here see these equations. Here the e power minus lambda 1 by 1 factorial. 1 by 1 is equivalent to 1 in this exponential series. Lambda e power t whole power 1 divided by 1 factorial is equivalent to in the exponential series x by 1 factorial. Like that lambda e power t whole square divided by 2 factorial is equal to x square by 2 factorial in the exponential series. The lambda e power t whole cube divided by 3 factorial is equivalent to x cube by 3 factorial. So now finding the e power x values by using the exponential series. The above term now rewritten as e power lambda into e power t. So that only we are writing finally e power minus lambda into e power t. In these equations, the two exponential function in this equation. So we taking the exponential function is common and power should be added. So e power lambda e power t minus lambda. Now the lambda is constant in the lambda is common in the power. So we are taking lambda in the outside in this power term. So e power lambda into e power t minus 1. After simplification we get e power lambda e power t minus 1. This is our moment generating function result. Using this moment generating function answer, we are going to find mean and variance. Our mean formula is expectation of x equal to d by dt into mx of t and put suffix t equal to 0. Here the mx of t answer is e power lambda into e power t minus 1. Now differentiating with respect to t in the moment generating function answer. Finally put t suffix finally put t equal to 0. Now differentiating e power lambda into e power t minus 1 one time. We get the result e power lambda into e power t minus 1 into lambda e power t. After differentiating the interchange these two terms, we get lambda e power t into e power lambda into e power t minus 1. This is equation number 1. In this equation, put t equal to 0. Now I am going to put t equal to 0 in the equation number 1. We get lambda e power t equal to 0 into e power lambda e power t equal to 0 minus 1. E power 0 answer is 1. So instead of we can write this equation is lambda into 1 e power lambda into 1 minus 1. So lambda into 1 we get lambda. E power lambda 1 minus 1 values is 0. So lambda into 0. Finally lambda into e power 0 answer is 1. So put lambda into 1. Lambda into 1 we get lambda. This is mean answer. Our mean values of Poisson distribution is lambda. Now we are going to find the variance of this Poisson distributions. The variance of x is equal to e of x square minus e of x whole square. Already we have calculated the e of x. E of x is the mean. So we have find that value. Now we are going to find e of x square value. So e of x square formula is d square divided by dt square into mx of t. Put in suffix t equals 0. The mx of t is differentiated with respect to 2 times with t. So that only already we have differentiated one time. So directly the substitute that answer is here e power lambda lambda e power t into e power lambda e power t minus 1. Now again the e power lambda into e power t minus 1 lambda e power t is differentiated with respect to one more time by using this formula d by dx into uv equal to uv dash plus v v dash. Here the u is the lambda e power t and v is the e power lambda into e power t minus 1. Now differentiating with respect to t we get finally lambda e power t into e power lambda into e power t minus 1 lambda e power t plus e power lambda e power t minus 1 into lambda e power t. This is after differentiating we get this answer. Once again repeat how to differentiate this term. U is constant, so lambda e power t is constant. V term is e power lambda e power t minus 1 differentiated with respect to t. In the e power x lambda e power lambda into e power t minus 1 differentiating we get again the same terms e power lambda into e power t minus 1. Now I am going to differentiate the power lambda e power t. The lambda is a constant, e power t differentiate we get e power t, constant values is differentiating we get 0. So lambda e power t plus now we are going to keep v constant. V values is e power lambda e power t minus 1. So that only now differentiating u value lambda e power t. After differentiating lambda e power t we get again the same answer lambda e power t. Now put t equal to 0 in these equations. Lambda e t values is 0 into e power lambda e power t values is 0 minus 1 lambda e power t values is 0 plus e power lambda e power t values is 0 minus 1 lambda e power t values is 0. Now after simplification we get lambda 1 e power lambda 1 minus 1 lambda e power values 1 plus e power lambda in e power values is 1 minus 1 into lambda e power values is 1. Now again simplification we get lambda e power lambda into 0 plus into lambda plus e power lambda into 0 lambda. After simplification again e power 0 put e power 0 values is 1. We get lambda into lambda square plus e power 0 values is 1. So lambda into 1 lambda. This is lambda square plus lambda is our e of x squared answer. Now substituting the e of x squared answer and e of x values in this variance formula, we get lambda squared plus lambda minus the e of x mean values is lambda then whole square. Now we get lambda squared plus lambda minus lambda plus lambda squared and minus lambda squared cancel. We get lambda, that is variance answer is lambda. final result, the Poisson distribution probability mass function is e power minus lambda, lambda power x by x factorial. Our moment generating functions of Poisson distribution mx of t equal to e power lambda into e power t minus 1. And our mean answer of Poisson distribution is lambda, and e of xy answer is lambda square plus lambda, and variance answer is lambda. Thank you all.